All right, time for lesson 5.2, dividing whole numbers by two-digit numbers. Here's your I can statement. I can divide whole numbers by two-digit numbers, and what I really want you to understand here is I don't expect mastery as you go through this the first time. Just watch it through, take your notes, and then if it's confusing to you, go back and watch it again, or maybe even 2 more times, just to really let it sink in. I don't expect you to catch everything the first time you go through this, okay? So, first thing we're going to do is we're going to review the methods we've learned to divide. And we're going to do that by looking at a single digit divisor because that's what we're used to seeing. So we've got 3,822 divided by 7. Okay, so we could do this place value sections, expanded notation, and the shortcut method. And the good news is all of these methods are going to work for our two-digit numbers too. So all division methods when we're dividing by two digits use the very same first step. So let's take a look at the problem 2048 divided by 32. And we are going to start with the place value sections method. Okay, so when I lay this out, I'm going to look at 32 and then I'm going to put 2048 in here. Okay, this first step is that we're going to round that divisor to the nearest 10. Okay, just to kind of help us figure out what to do. So we've got 32 here. I'm going to round that to 30. Now when you round a number down, in this case we're bringing 32 to 30, we put it in parentheses underneath. If we were to round this number up, let's say this was 38, we'd put 40 above. So it just depends on the position where you're going to put those parentheses. So when you round a number up, you'll put the parentheses number above there. Okay, and you may see some of those as we start to work through these together. Now, when I look at this problem, I'm really going to be looking at it to simplify it in my mind. I'm really going to ask myself how many times 30 goes into 2,000. Now, I know that sounds like a lot, but it's really not too bad. And it's a lot easier to think of than how many times 32 goes into 2048. Okay, so the first thing I'm going to ask myself is about how many times 30 goes into 2,000. Okay, well, I'm going to look at how many times 30 goes into 200 first, because that's easier for me to think of. You know, I could even skip count by 30 to get there, but I know that 6 times 3 is 18, so 6 times 30 would be 180. That'd be close. Okay, so there'd be 6 30s in 200 without going over. So I'd ask myself next, how many 30s are in 2,000? Well, what's the big difference between the 200 and the 2,000? Well, it's that 0 that's sticking out here at the end. If I look at my answer of 6 here, I'm going to take that 0 that was on the end, and I'm now going to make this into 60. Okay, so there are about 60 30s in 2048. Now we got to move on to step 2. And step 2 is to multiply using the original number. Okay, so now we're going to take 60 times 32. Now you may have to go off to the side and just kind of write that problem out and multiply it out. You do what you need to do to help you there. That's totally okay. Okay, you might have to add that extra step in there. Some of you will be able to handle multiplying this mentally, and you can do that by breaking this down. I already know that 30 times 60 is 1,800, and I just got 2 more 60s here, which is 120. I take 1,800, I add 120, and that's 1,920. And again, if you can't do that in your head, don't worry about it. It's not expected. You can certainly do it on a piece of paper. Okay, so we're going to go ahead and subtract. We get 128. We're going to draw a new box. We're going to bring our 128 up there. How many times will 30 go into 120? Because I'm going to forget about the 8 on there. Well, I know 3 will go into 12 4 times. So 30 will go into 124 times. So when we multiply that out, we actually get a number that doesn't have any remainders. Add it up across the end and we get 64. So let's look at this exact same problem. Now let's look at it from an expanded notation standpoint. Okay, so first step, still going to round that divisor. Okay, that's the same first step in all of them. So we get 30. Okay, and I'm going to ask myself the same question I asked on the last time, how many 30s are in 2,000? Well, we know from the last one that it ends up being 60. Okay, so I end up multiplying. Okay, and I get 1,920. Okay, by multiplying 32 times 60, just like in the last one. I subtract, I get 128. Again, we know that 4 times 32 equals 128 from what we already looked at. And I get a 0 remainder here. Okay, and now I take a look at this and I add these up, and it's 64. Okay, exact same answer, different method. Okay, finally, let's take a look at the shortcut method. Okay, there's going to be a slight change here, and you'll see it as we start to ask the questions ourselves. Okay, so we're going to go ahead and round that divisor first, just like we've done on every other one. Now here's where it gets different. Instead of asking myself how many times 30 goes into 2,000, I'm going to ask myself how many times 30 goes into 200. Because when I look at this problem here, first thing we check is, will 32 go into 2? No. How about 20? Nope, still not. 204, yes. But I'm going to look at 30 into 200. Okay, and again, we've done this enough. We know that that's going to be 6 times. That's going to end up being multiplication with the original number Sorry, I got a little off track there. So we're going to do 6 times 32. Okay, so 6 times 32 is going to be 192. We're going to subtract, we get 12. Okay, and again, 6 times 30 is 180. 6 times 2 is 12. 180 plus 12, that's where this 192 comes. But again, if you need to do that, a little bit of work off to the side, you can do that. Okay, now we are going to use the check step from our poster here, okay, because that becomes really important. So is 12 less than our original divisor of 32? You bet. So we're going to bring down the next number. That gives us an 8. We know that that's 4 times. We subtract that 0. Of course, 0 is less than 32, so now we know our answer there is 64, and that's using the shortcut method. So again, it doesn't matter what method you like or you use as long as we're working towards the same answer at the end here, okay? So I'm going to have you try one. In a moment, I'm going to have you pause this video, and you're going to try this problem, and then after you've done it in your book, or in your math notebook, you're going to play the video and just check your work and see how you did, okay? So pause and try now. Okay, so let's go through this together. So I'm going to use the place value sections method. It doesn't matter what method you use. Let's just see if we got the same answer, okay? So I'm looking at 18 into 1061. I'm going to round that divisor. This time I rounded it up, okay? So you can see I put the number above here. I mentioned that earlier, okay? So I'm going to figure out how many 20s go into 1,000. Well, I know how many 20s go into 100. That's 5. So if I'm going into 1,000, that's one more place value out. That's 10 times bigger. I'm going to put a 0 at the end, so it's going to be 50. Now I have to remember what I'm going to do with step 2, which is multiply using the original numbers. Okay, and 18 times 50 is 900. When I subtract, I get 161. And again, if you need to write this off to the side and do 18 times 50 and multiply it out, you may do that at any time. Okay, you can also do this mentally. If you know that 20 times 50 is 1,000. 18 is 2 less than 20, so I've got 2 50s that I take away from 1,000. 2 50s are 100. That's where that 900 comes from. And again, if that's confusing you to in your head, just do it on paper, okay? So I'm going to bring my 161 up here. How many 18s go into 161? Well, I know how many 2s go into 160, so I know that 20 goes into 168 times. So I'm going to multiply. When I use my original number, 8 times 18, and that's the thing you really got to remember. Once you figure out about how many it is, you must go back and use the original number. That's crucial, okay? And I get a remainder of 17. So when I add this up, I get 58, remainder 17. Remember that I am trying to get you to work towards always putting that as a fraction. R is okay because this is the first time we're looking at double digits, but I'd like you to be able to know that that's also 58 and 17/18, okay? Here's something you want to watch out for when you're doing these. Okay, and that is overestimation. So let's kind of walk through an example here, okay? So I'm going to round this to 50, okay? I know that 50, I'm going to ask myself how many times, and I'm going to use this will be the shortcut method, okay? So I'm looking at 54, won't go into 2, won't go into 25, but it will go into 253. So I'm going to ask myself, how many times can I get 50 into 250? Well, that works out nice because it's 5, because 5 times 5 is 25. So I'm going to put that up there. But wait, when I use the original number, look at my product. Okay, so how do I know that the estimated digit 5 is wrong? Well, because when I look at it, I can see that product 270 is too big for me to subtract from 253. That's not going to work. So the big question is, what do I do now? Well, the easy thing to do is you try a digit that's 1 less. Okay, so in this case, 1 less would be 4. So I'm going to get rid of that, and I'm going to use 4 times 54. It's an easy substitution. We can just notice right away, that's not going to work. I'm going to go back and make that 1 less. I get 216 when I multiply that out. Then when I subtract, I get 37. I'm going to check 37 is less than 54, so I'm going to bring down my next number. I'm going to ask myself the same question. How many 50s go into 370? Okay, well, 7 times 5 is 35, so that's going to get me close. So let's see if that's going to work. When I multiply it out, 7 times 50, 350, 7 times 4, 28, 350 plus 28 is 378. Works out that I have no remainder, okay? So here are your practice problems for tonight. Don't forget to do the rounding step. Go back and review the steps if you're not sure what to do. I strongly recommend you write the steps in your math notebook. It's going to be a very helpful tool, especially as you're working through your seat work. So go ahead and solve those 2 problems. Here's your guiding question for the night. How do you know if the estimated digit is too big? If that happens, what should you do? And just make sure you're ready to discuss that. And then I would like you to create another problem of your own. Remember, this should have a 2-digit divisor, and there should be 4 digits inside the dividend when you are doing this. And we'll see you tomorrow.